right, my friends, I think I'm getting everything set the right way. There we go. Let me let the bell ring. It's 7th hour. All right. So for this, oh, there we go. I wanted that to move out of the way. For this lesson, it's lesson 5 of module 5 on volume. So today we were working on using the volume formula with the information that we're given. So if you look at number 1 with me on P45, it says, I feel like it's a little bit, there we go. Nicole designed a jewelry box in the shape of a right rectangular prism. The height is 2 inches. The length is 3 times as long as the height, and the width is twice as long as the height. If the box needs to have a volume greater than 50 cubic inches, will her design work? Why or why not? So we are given a lot of information here. It is a right rectangular prism, so we know we can use that volume formula. The height, if I kind of just sketch it over here, the height is 2 inches. The length is 3 times as long as the height. So I've got my 2 inches. I've got my length is 3 times as long. So if I think of 3 times as long as 2 inches, that tells me that the length is going to be 6 inches. And then the width, how it goes kind of back, the width is twice as long as the height. So again, twice as long as our height. So that means my width is 4 inches. Now I just realized I was using a pen like I would do in class, but I want to switch to a pencil. So I'm going to take that information. I have my length and my width and my height. So I'm going to do 6 times 4 times 2. So 6 times 4 is 24. 24 times 2 would be 48 cubic inches. If the box needs to have a volume greater than 50 cubic inches, will it work? So we would say no. And it says why or why not? Well, we just explained if we have that information and we follow our formula, we know that it is not greater. All right. We're going to find the volume of these next figures. You can see they are all right rectangular prisms. So we can just plug in that formula. Remember, length times width times height. That will give us our volume. So I see the length is 5. I see the width. Oh, let me look. I like the width here, but I'm going to find that parallel side. The width is 3. So I have 15 and the height is 6. I got a little slanty here, but if you follow along with me, that shows me that the volume is 90 cubic inches. Number 3, I can see the length again. The width matches up here parallel and the height. So I have 4, let's do it the right way, 11 times 4 times 7. And I said, let's do it right. I just wanted to follow the length times the width times the height. So let's see, if I do 11 times 4, that gives me 44. I'm going to multiply that by 7. 7 times 4 is 28. Regroup. 7 times 4 is 28 plus 2 is 30. 308 cubic centimeters. Remembering to label properly. Not only do we need that label of measurement, but we need that exponent, or it could have looked like that for cubic centimeters. Over here, it would have been 90 cubic inches, right? Please label properly. Okay, let's move on to number 4. I see a length. I really can use, I'm going to use this for the length, 6. I see a width. How wide is it? I see that 15. And I see the height of 9. All right, I'm going to go with 15 times 6. I'm going to rewrite that and get an answer of 90. 90 times 9, I'm going to do 9 times 9 and hang that 0. 9 times 9 is 81. The 0 drops into place, and we will get 810 cubic inches. There we go. The last one like this, I see a length, and I see a width matching up above, and a height. So I have 5 times 5 times 12. I'm going to do 5 times 12 first, since I can multiply in any order, because I know 5 times 12 is 60. I'm going to then multiply by 5 and hang that 0, and I'm going to get 300 cubic feet. And I'll write it both ways for us. There we go. All right. Let's take a look. We've got a little history here. Wouldn't Mr. Tullis be proud? Let's see what it says. After skyscrapers first started being built in the United States, the government passed the Height of Buildings Act of 1899. This act made laws for the maximum heights allowed for types of buildings in Washington, D.C. If a wooden building in the shape of a rectangular prism was built to the maximum height of 12 meters, what would be the volume of the building if its base measured 20 meters by 15 meters? Write an equation to show how you found your answer. So we talked about the base of our rectangular prisms in class today. Remember, if we're finding the base, the two measures that give us the base are the length and the width. So if we have the length and the width for our base, that's 20 meters by 15 meters, and it's a maximum height of 12 meters. So we have our base that equals 12 times 15 times 12 meters high. So I think I'm going to do 15 times 12 first over here. 15 times 12. If I do that work, I'm going to move on and do that. Hopefully you are doing it with me. Pause your video if you need to at any time, remember. And we're going to get 180. That's our 15 times 12. I did that first because I wanted to work with this 0. So if I have 180 times 20, I'm going to ignore both of those zeros for just a moment. Do 18 times 2. I know that's 36. I'm going to drop both zeros into place, and we're going to get an answer of 3,600 cubic meters. 3,600 cubic meters. Wow. All right. We should ask Mr. Tullis if he knows about this Height of Building Act from 1899. I'd be interested to know. All right. The next side is the test prep. So if you want to pause right here and take this test as if you were doing it in class, come back and look, or work and listen along with me. Here I go. A package is in the shape of a right rectangular prism with the dimensions shown. What is the volume of the package? So I can see the length and the width and the height. I'll write that out. I'm going to start, I think I'll do 13 times 8. 13 times 8. When I do that, I get 104. So 104 times 12. Done with the ones place. I would get a final answer of 1,248. I'm working with inches, so I'll do cubic inches. I'll write it that way. Okay. Select all the dimensions that a right rectangular prism with a volume of 756 cubic feet can have. We're going to have to do some checking on all of these, right? If I have to select all of them that fit a volume of 756 cubic feet. So I'm going to keep working out here to the side. If I have 12 times 14 times 3, I'll do 14 times 3 and get 42 times 12. And we get 504 cubic feet. I don't want A. 14 times 6 times 9. 14 times 6 times 9. 6 times 9 is 54 times 14. There I go. I get 756 cubic feet. Letter B is a good one. All right. I may need to get, I'm just going to get a sticky note because it's close, just so that I have some more space here. If you need an extra piece of scratch paper, find that for yourself. 21 times 9 times 4. That's our next one to check. I have 9 times 4 is 36 times 21. So when I do that, I will get, oh, another good one, 756 cubic feet. We have 3 by 8 by 21. I'm going to do 8 times 3 is 24 times 21. And I get 504. B is not good. One more. Hang in there. We can do it. I love all the hard work that you're doing to learn about volume. One more. 14 by 18 by 3. I'll do 18 times 3 gives me 54. 54 times 14. And I get 756. That's what I was looking for. All right, so it looks like we have B, C, and E that are all good answers for number 8. Number 9, a right rectangular prism has a length of 5 feet, a width of 3 feet, and a height of 2 feet. So I don't need to draw this out. I see the length and the width and the height. I can simply write out the formula, length times width times height. And then I can go, I'm going to do 3 times 2, that's 6. 5 times 6 is 30. We're talking cubic feet then for our label. The answer would be C. Spiral review. Oh, some of you have a little bit of trouble when it's an irregular figure. Imagine that this is maybe pushed back into a corner. All of these tall blocks, there has to be something underneath them, right? So here I can see, here's one block. If I see 2 blocks in front here, that little tower, I'm going to keep track on the side. If there are 2 blocks here behind that, that tower is 1 taller. That has to be 3. And then the same thing right next door, there's another matching tower. There's another 3. In front of that, there's a matching shorter tower of 2, and then back to our 1. So if I add all of those up, I have 3, 6, 9, 11, 12 unit cubes. All right, don't be fooled by those hidden blocks. Evaluate the expression. I see parentheses. I'll do that work first and subtract. Bring everything else down. No exponents. Multiply, divide. Yes, I see dividing. I'll do that. Add, subtract. Order of operations, say what? Our answer is 13. All right. Thank you for working with me and joining in. Get some IXL practice if you feel you need it, and I will see you next time.